Hello everyone and welcome. Thank you very much for joining us today. My name is Peter Jones and today I will be running through with you some of the 3D printing capabilities available in SpaceClaim. So those of you that are not familiar with GoToWebinar, it's really simple. There's just a box on the right hand side where you can leave your questions and comments, and what I'll do is I'll do my best to answer as many of those at the end of the webinar. Anybody that leaves a question that I haven't been able to answer, please do drop us an email, and we can always arrange a one-to-one demo for you. Okay, so what is SpaceClaim? SpaceClaim is a groundbreaking CAD tool. It's intuitive, it's really easy to use, and it's ideal for anyone that's involved in manufacturing. It uses a direct modelling concept, so none of the structure tree is changed. You can bring in almost any file type and quickly and easily prepare that model for manufacturing, as well as designing and editing that part. But today what we're going to do is we're going to focus on the STL capabilities within SpaceClaim. So preparing models for 3D printing. You might bring in a file that's got some holes in it or corrupt data, and it's fixing that model in the quickest and easiest way so that you can get it straight out there and you're manufacturing it on your 3D printer. So what I've got is I have a few examples to run through with you today. So I think the best thing to do is to jump into the CAD and we can get into that. Okay, so if I open up my example with SpaceClaim, you can bring in almost any file type. Really, it's really great. You can bring in CATIA natives, SolidWorks, Rhino, Inventor, step files, IDIS files. But today we are going to concentrate on the STL files, really. So they're 3D printed models. So the first example I have here is an example of some scan data. Really, you can see visually that there's problems with this model. So there's some holes in there. Yeah, it's just not watertight, and you couldn't, in its current state, you couldn't put this onto the 3D printer. You wouldn't be able to create what you wanted. So although you can see this visually, SpaceClaim has these check capabilities. So we're working within the facets tab. I'm going to check the mesh first, and as you can see, there's some issues with this. So the mesh is multiple pieces, it's not watertight, it's self-intersecting, and it contains non-manifold vertices. So there's loads of options you can go through to fix this. They're really easy. So first we can go through, we can check all the holes. So if I zoom in on one, you can see what SpaceClaim does is it creates a mesh across that hole and patches it, incorporating the triangles that are next to the hole, so incorporating existing curvature in the model. So you can go through and you can manually fix those holes, and you can also go through and you can manually fix sharps in the models. So you can just look in and see where there's a little sharp area. SpaceClaim you can go through and you can just click on those and fix those. But the quickest way to get yourself into a level where you're ready to 3D print is just to go on and click the auto fix. So the auto fix will go through and it will fix the holes, it will fix the sharps, over connections and intersections, and get you to a point where you can 3D print as quick as possible with as minimal effort required, really. So as you can see now, we have a model that would be great. It'd be fine for 3D printing. That would go straight onto the 3D printer. If I check the mesh, I can prove this. So there's no problems with this geometry. But as I spin around, you can see that some areas like this here are where because of the scan data was so poor, it's made a blend across this hole. But what we really want is is we want a proper through hole here. So in SpaceClaim, because it's a complete modelling package as well as the STL preparation, you can do some reverse engineering on this model and start to edit this and give yourself more control. So if I create a quick plane on here and I bring it up to intersect our hole, I can sketch onto this plane and I can start modelling. SpaceClaim allows you to model straight from the mesh, which makes it really easy. So I can start creating a hole here. So I've got a surface now of where I want my hole. If I pull this in both directions, I now have a solid model that I'm going to use to cut away the mesh and create the hole. So what you have to do first is to create this, is to convert this solid data back into facets. We have the conversion function, where you just click on your solid model and it converts it straight into mesh. And then now we're working with two mesh models, we can subtract one bit of mesh from the other. So it's really useful. And then now you have a nice clean hole there. And of course, with SpaceClaim, you still have the same push and pull functionality. So even when you're working in mesh, so if I grab on that bottom surface of the hole and I pull that up, then you can see you can still really easily edit this. So you can bring it up and down within the model. And of course, if you want that extra control, you can click onto some of the mesh and you can drive that dimension. So if I need the hole to just be 10 mil from the top, there you have it. So you have something that's it's still got the same control and it's really easy to use. So you can bring in a model, you can quickly and easily edit, and then you can reference the existing mesh to reverse engineer and give you exactly what you're looking to 3D print. Okay, I'm going to jump into my next example now. So if I open this up, so what we have here is similar to the last one. It's an STL file, but this one it looks like it's been designed in another CAD platform, because the STL package, the STL quality is pretty good. But what you might want to do for manufacturing is edit this and make little design changes to make it easier to manufacture. So as I showed a second ago, you still have the same push and pull functionality even when you work with mesh data. So if I double click onto any of the triangles here, I can pull them up and you can give more thickness or reduce the thickness of any feature. If I double click on the inside, you can do the same here as well. So you can really easily edit an STL file, which in other CAD platforms that can really struggle with. I can come down here and maybe these parts here you think, I need to thicken these up, they're a bit too thin, so I pull this out. But as you can see, if you focus on this area here, the mesh is all sort of interlocked and there's relationships between each triangle. So sometimes when you're pulling out a feature, it can really put strain on the mesh and it's bringing in these sort of red areas. So what a nice thing you can do with SpaceClaim is you can create your solid geometry and then merge it back together. So if I copy and paste this surface here and hide the rest of the mesh, SpaceClaim has full Windows functionality, so it's just Control-C, Control-V to copy and paste any feature. I can then quickly and easily convert this back to a solid, so convert this mesh surface into a normal NURB surface. And if I bring that back into my STL model, if I grab my surface here, I can pull this out to, maybe we want it 3 mil thick. I jump back into facets now, convert my solid body to a mesh, and then merge my existing STL file with the new part I've created. And now if you look in the structure tree, we just have one single part. So I'll just quickly run through that one again. So what you can do is you can double click on any surface, Control-C, Control-V, and then you've copied that surface. If I convert to solid and merge the faces, you're left with just one single surface. And then what I can do is I can use SpaceClaim's pull function, just bring that across to 3mm, jump back into facets, convert that to mesh, and merge the existing body with the new part that I've modelled. So it's really easy, really simple, and you can make those design changes you need to create the best possible 3D printed model. So I'll jump into my next example now, and we're going to have something a little bit different. So what we have here is an example of some scan data here. So it's single surface scan data of someone's teeth. And what we can do initially is check the mesh, and it tells you here it's not watertight. So what that's saying is it's got this large open cavity here, and you can see by the different coloration, like the outside surface in this blue and the inside it in the pink. You can see it's just a large open surface, single surface model. And what you would want to do is create something that's nice and watertight for 3D printing. But if I was just to do a blend across the top here, it might not be what we're looking for. We might want to create something with a bit more design, or a plinth or something for this to sit onto. So I'll show you that now, how you can do some reverse engineering and solid modelling and then merge it all back together. So if I double click on the edge here, it gives us all the curves along the top edge of this scan. If I copy and paste those and hide the model, we're left with the outline of the teeth. If you zoom in, you can see the problem with this is it's got loads and loads of, it's made up of loads of little curves because of all the triangles it's coming from. So in SpaceClaim you can simplify this in repair, and you can fit the curves into something that's a lot more easy to handle. So I'll combine this together, and then now if I bring back my model, and we will pull these up in the direction. So I'll come off on the front here, and yeah, so if I bring this up, then what I can do is I can grab all these curves and pull them in the direction of this plane. I bring back my model here. So what we want to do is we want to quickly use combine and just chop off this top of the top of the surfaces we created to make something that's nice and flat. And then I use fill to create a nice bottom surface here. So what we have there is pretty much what we're looking to achieve, is a nice sort of sturdy model that we could fit onto a 3D printing bed and maintain all the detail that we require. So what I want to do now is quickly convert this surface model back into mesh, and if I just reverse it so we have all the outside on the same, and then what we can do is we can merge these two separate pieces of mesh, and we'll get one single body. So you can go from here, and you can see that in the structure tree it's highlighted with a like kind of like a pinkish colour to the mesh. So that's saying that there is something wrong here. So if I check the mesh, it tells you, yeah, we're not watertight at the moment. So, and that is just because where I simplify the curves, they're not quite exactly marrying up. But what we can do is we can auto fix that, and it will just cap over any areas where the mesh is no longer watertight and fix those issues. And there we have it. You can see the symbols change slightly from a sort of a triangle with a pinkish mesh to just a nice bright blue, saying that that mesh is perfect and ready for 3D printing. But I mean, additionally, something else you might want to do as well is if you've got lots of different files, you might want to customize each one with a bit of text or something like that. So I can just show you how to do that now as well. So if I click on the bottom here and sketch a little surface on the bottom, and then I will add some text onto this area. There we go. So I can then now project this text onto the surface. If I delete my annotation plane, we now have some usable geometry embedded in that surface. I'll delete the edges of it and remove the areas that we don't need. And then quite simply we can pull this surface up into a solid body, and then if I select all those solids, I can convert them all at once into mesh and then start to merge each of these mesh bodies with the existing model we have of the teeth. So you can very easily customize any bit of scan data or any STL file you receive, and identify one from the next. Especially when you're doing a large 3D print, you can you can identify whose is whose. Really straightforward. Okay. So yeah, you just go through and you just one by one you start to merge these bits of mesh together. And I think maybe a quicker way for this would probably have been to just merge all as one, but I mean I'm almost there now, so I'll just do these last few bits. And there you can see, if you go over to the structure tree now, we just have one single mesh body from all those parts created there. Okay, and I'll jump onto my final example now. So what we have here is something similar to our last model. So it's some scan data. It's single surface, but there's another quicker way of getting this ready for 3D print. So if you want to just quickly thicken it up, give this single surface a thickness, and then pop it straight into the printer, that is really easy. So we have this thicken option here. So if I click onto the face, maybe we'll make it 2 mm thick, and if I zoom in here, you can see that it's been given a thickness. So let me go back a step on that. If I pop down here and I'll show you the thickness. So if I click on this and then go 2 mm thick, you can see it really easily, quickly thickened up that model. So now that's a watertight solid ready to go straight on the 3D printer. Sometimes with this kind of scan data, the model might be really data heavy, so there might be loads and loads of triangles, and you would like to reduce them. That's something that's really simple to do. So it's got this reduce function here. So I click on the model, and maybe I want to reduce it by 50%. I zoom in slightly, and then tick that off. You can see that the mesh becomes looser as the triangles are being reduced, making it a less data-heavy model. And that can be particularly common with scan data. The scanners can capture really fine detail, much more fine than your 3D printers can actually print. So sometimes to process these models and work with them more easily is definitely worth reducing the quality. So what you should see in a minute is where the triangles are quite tightly packed, they'll become less. They'll become less and looser. And there you go. So you can see they are slightly less packed, but you're still getting a really good quality 3D printed model there. One of the features I wanted to show you as well on this is something that's new to 2016. Is the skin surface. So what you can do in skin surface is you can create a NURB surface from tracing over your mesh model. So if I start off now and start creating my area that I want to create the surface, just double clicking to change direction, and you just want to get 4 control points and then marry them up at the end. So you can see here, this is where my server is going to be created, and you still have these points here. So if you want to include certain areas, you can still drag and make sure that you've got everything within that one surface. And then once you're happy with that, you can just tick that off, and SpaceClaim will create a surface from the mesh. So it's really, really useful if you want to do some reverse engineering, if you want to incorporate some of your scan data into your models and model from them. So there we go. We've got our surface here, and if I hide the mesh, you can see it's a nice surface there, without any of the triangles. Really simple, smooth surface. And I'll just show you again. You just click off from the next one, and then you can start to build up your next surface. So this is a really unique feature. It's something that I think is something completely different to other CAD packages. It's a really, really useful feature if you want to take your mesh file and go back to surface and solid modeling. So I mean, I can go through and do the whole thing, but I think in sort of true Blue Peter fashion, I have one I made earlier, and I'll just show you what that looks like. So here we go. This is the completed model that I made earlier, and if I hide my mesh, you can see it's a full surface model of that face, and it just really simplifies it and makes it into something that's easier to work with. And of course, you can measure these. You can measure the deviation between the surface model you created and the mesh model. So if I click on this deviation tool in Measure and select the 2 bodies, it will then go through and it will check all the points in the mesh as compared to the surface, and it will measure how accurate the surface model I've created is. So you have lots of different tolerances and stuff here. So at the moment my tolerance is set at 0.01 millimeters. You can obviously tighten that or loosen that depending on what you're doing, and it will go through and it will give you a visual representation of where your surface model is in and out of tolerance, which is can be really, really useful. And there we have it. So what you have here is it shows you where the surfaces are in or out of tolerance. So the green obviously is areas where it's within tolerance, and the only areas out here where it's out of tolerance are the areas where I hadn't created a surface. So it's only around the edge where I haven't actually created a surface is where it's out of tolerance, and the rest of it is all within 0.1 millimeters. So really good quality surfaces. Okay, so those are the examples I have for you today. I've got a question here I've got time for is can you convert a whole solid model back to a mesh model? And yeah, so similar to what I showed earlier with the surface, but can you do that with a whole solid body? Yeah, okay, let me show you how you do that. So if I go to New Design, and I'll quickly create something. So if I just quickly create some simple shape as a solid, and what I'll do is convert it to a mesh and then back to a solid. Okay, so that's quite a simple shape really, but what we can do is I can bring it into facets and convert it. And just as I did with the surface earlier, I can convert the whole thing back into a solid body. So you just right click on the mesh, convert to solid, merge faces, and that will try and create the most simple solid models possible. Of course, with STL and mesh data, it does split up any rounds into a group of straight lines. So because of the triangulation, that you are going to lose those straight rounds. But with SpaceClaim, you can easily you can easily remodel those back in. So using the fill tool, I can just grab over an area, I can fill that, and if I grab over another here, I can fill it. And then what we can do is just fill in these poor faceted edges and create a nice, we can just remodel in the rounds and create a nice smooth round. So we've got the same shape from the STL, and we can bring these in. So I mean, it can be really useful actually, that sort of from STL to solid model. It can save a lot of time, especially when you're dealing with something more complex than what I've got here, because obviously this isn't maybe the best example, but it does show that you can quickly and easily go straight from mesh to solid. So I think actually that's pretty much all we've got time for today. Thank you very much for joining us. We're going to be doing these webinars the last Friday of every month pretty much, so stay tuned, and if you've got any questions or more information on SpaceClaim, please drop us an email at 3d@cadventure.co.uk. Thank you very much.